Hi, this is Mrs. Kidman, and in this video, we're going to be discussing how we can apply different theorems on lines and angles. So let's quickly just review what different parts of lines and angles are, some of those theorems that we talked about. Now, vertical angles, remember that vertical angles are always congruent. An example of vertical angles would be things like 1 and 4, 2 and 3, 6 and 7, and 5 and 8. Those are all vertical angles. Notice how they're right across from each other and they are congruent. Next, let's take a look, maybe, at our corresponding angles. Now, corresponding angles are also congruent, and corresponding angles are correspondings if they're on the same side of the transversal and on the same side of their parallel line. So, for example, angle 1 and angle 5 are corresponding, 2 and 6 are corresponding, 3 and 7 are corresponding, and 4 and 8 are corresponding. So again, they're always congruent to each other, but they're corresponding on the same side of the transversal, same part of the parallel line. Okay, let's take a look at our next one here, alternate interior angles. Those ones are also congruent. Remember, they're on the inside of our parallel lines, so 3, 4, 5, and 6. And alternate interior means that they alternate the side of the transversal that they're on. So 3 and 6, and 4 and 5. Now those are also congruent. Similarly, alternate exterior angles are also congruent. So alternate exterior angles are just like alternate interior angles, but instead of being on the inside of our parallel line, they're on the outside. So what we're looking at here are angles 1 and 8 compared to angles 2 and 7. Okay, now the next type of angle that we're going to talk about are called same side interior angles. And those ones are not congruent, but they actually add to 180 degrees. And you can see why. The same side interior angles, we've got angle 3 here and angle 5. Notice how this one is the small angle and this one's the big angle. Now 3 and 4, as they're next to each other, you can see they make a linear pair. And 4 and 5 are alternate interior angles or congruent. So because they make a linear pair and these are congruent, those must also add up to 180 by that definition. Similarly, same side interior angles also include angle number 4 and angle number 6. Now, the last ones that we're going to look at here in the case of these angles are same side exterior angles. So similarly, just like the same side interior angles, these ones also add to 180. They're just on the outside of the parallel lines rather than on the inside. So that's going to be angle 1 with angle 7 and angle 2 with angle 8. So again, they're on opposite side, they're on the outside of our parallel lines, but on the same side of our transversal there. Okay, so quick refresh. Vertical angles, congruent. Corresponding angles, congruent. Alternate interior and alternate exterior, congruent. Same side interior and same side exterior, however, are supplementary or add to 180 degrees. Okay, so a quick reminder on supplementary angles versus complementary angles. Complementary angles are angles that add to 90 degrees. And usually you'll see them with something like this, where they have that right angle built in. And supplementary angles are ones that add to 180 degrees. And those ones are supplementary, like we can see with those same side interior and same side exterior. But also, whenever we have a linear pair, they are also going to add to 180. So based on these angle properties and these line properties that we've seen, let's go ahead and solve for some angles here. Okay, so in this first example here, we're looking at two angles, and we want to figure out what those angle measures are. Well, the easiest way to do that is we can use that x and solve for x. Well, I know that these are alternate exterior angles, and alternate exterior angles are congruent, which means they're equal. So I can do 8x plus 9 equals 9x plus 2. And I can solve for x and then plug it back in to figure out what it is. So I'm going to solve for x, subtract 8x from both sides, subtract 2 from both sides. These cancel, and we end up getting 7 equals x. So 7 is x, which means if I put 7 in, 9 times 7 plus 2, 9 times 7 is 63, plus 2 is 65. So that means this angle is 65 degrees, and this angle is 65 degrees. Fantastic. Okay, so let's do the same thing over here. We're again applying those properties. Now these are alternate interior angles, and alternate interior angles, as seen before, are also congruent, so we can set them equal to each other. 6x plus 10 equals 64. In this case, we're going to solve for x, even though we know both angles are going to be 64 degrees. So let's figure out what x is. Well, I'm going to subtract 10 from both sides. Subtract 10, and we get 6x equals 54. Divide them both by 6, and we get x equals 9. So x equals 9, and both of our angles here are 64 degrees. Fantastic. Okay, let's take a look at these next ones here. Again, we're applying something a little bit different. We want to make sure we use all of our properties that we have. So in this case, we've got two angles that are both on the same side of the transversal and both above their parallel lines. So these ones are corresponding angles. And again, corresponding angles are going to be congruent. And so with them being congruent, what that means is we can set them equal to each other. So 130 degrees equals x plus 134 degrees. So we can solve for x here. I know that both of these are 130 degrees because I know that they're congruent. Now let's figure out what x is. I'm going to subtract 134 from both sides, and we end up getting that x equals -4. Now, that doesn't mean that our angle is -4 degrees. It means that x in this case is -4 because they're both equal to 130. Awesome. Now let's take a look at these next ones. 18x plus 9 and 81. Now these ones are both on the inside, but they're not alternating. They're on the same side. So remember, same side interior angles are the ones that add to 180 degrees. So we want to add these to 180. 18x plus 9 plus 81 equals 180. And we can use that to figure out what this other angle is by solving for x. So let's go ahead and do that. 18x, 9 plus 81 is 90, equals 180. I'm going to subtract that 90 from both sides, and we get 18x equals 90, divide by 18, and we end up getting x equals 5, I think. Let's double check that. 90 divided by 18 is 5. Yes, x equals 5. Fantastic. Okay, so x equals 5. If x equals 5, we can plug that x back in to figure out what that other angle is. So 18 times 5 is 90. And 90 plus 9 equals 99. So this is 99 degrees. Now, another way that we could have done that is recognize that this is 81. So this one has to be 180 minus 81, which is 99, and set those equal to each other to solve for x. Either method will work great. It just depends on the context of our question. In this case, we want to find both. Okay, now these next ones here are not parallel lines cut by a transversal. This first one here is a complementary angle, so they add to 90 degrees. So let's solve for b. So b plus 62, because they're complementary, equals 90 degrees. I can solve for b by subtracting 62 from both sides, and 90 minus 62 is 28. So b equals 28 degrees. Awesome. Now these other ones here are not right angles, but they are a linear pair, and a linear pair adds up to 180. So b plus 105 equals 180. Well, if I subtract 105 from both sides, I end up getting b equals 75. This is 75 degrees. Fantastic. And then we're going to look at these last two. Now this one over here, b and 60, this relationship is special because these are actually vertical angles. So they're exactly across from each other. And what do we know about vertical angles? That's right, they are congruent. And so b actually also equals 60 degrees in this case. And then lastly, we have this one over here. Now, this is a straight angle that we're looking at, or a linear pair. All three of these add to 180. So we've got our 90-degree angle, because this is a right angle, plus 43 plus b equals 180. Now I'm going to subtract 90 from both sides and get 43 plus b equals 90, just to simplify our math. And then we subtract 43 from both sides, and b equals 47 degrees. Awesome. Okay, so that's what we're going to do in this lesson, is we are just applying those properties that we've learned. We've learned that alternate interior angles are congruent. We've proven that to be true. We've proven that vertical angles are congruent. Now we're just going to apply those in order to figure out whether we have the same angle, figure out what x is, things like that. We can use these concepts to then discover other things, which is just so awesome about geometry. It's like geometry meets algebra, which is the best. So if you have any questions, feel free to reach out. But that is our video on how we can apply different line and angle theorems to solve and find different angles.